This video will cover section 4-1, sample spaces and probability. The first thing we want to cover is the definition of sample space, because this is going to be critical in terms of some things we do later today. So the sample space is the set of all possible outcomes for a probability experiment. And I emphasize the word all there. What can happen? Everything. That's what constitutes a sample space. And we'll get to that in more detail. Now, second thing we want to cover is the types of probability. I'm going to deal with the last one first, and that's subjective probability, because this is the only time you're going to hear about it. Subjective probability is basically based on an educated guess. It's not something that we can calculate. Different reasonable people can come to different answers. This is the first, last, and only time you're going to hear about it in this course. Where we're going to spend a lot of time, though, is classical probability. And classical probability is the probability of an event is the number of ways the specified outcome can occur divided by the total outcomes. And you'll see there's a mathematical representation of that here. The probability of an event is equal to the number of ways the event can happen divided by the number of things in the sample space. Simplest example for this is flipping a coin. Well, we want to know the probability of heads. Well, when we flip a coin, two things can happen. It can come up heads or it can come up tails. So the size of our sample space is 2. The number of ways it can be heads is one of those. So if we flip a coin, and assuming it's a fair coin, probability of flipping heads, the numerator's 1, denominator's 2, it's 1 over 2, or 0.5. And that does bring into call the next thing, the rounding rules for probabilities. Probabilities should typically be expressed as reduced fractions. I know lots of people don't like fractions. That's fine. Decimals are always okay too. Or rounded to 2 or 3 decimal places. I would say for the purposes of this class, go with the 3. It's a better thing if you just safer, we'll go with 3. It does point out one particular exception when the probability of an event is extremely small decimal. So you've got more than 3 decimal places there before you get to the first non-zero decimal, or I'm sorry, first non-zero digit. You can go to that point. All right, we won't get too tangled up in that. Now, the third type of probability, and we'll see some examples of this, is empirical probability. It has a lot of similarities to classical probability, but there is a difference in terms of the source of the data. In classical probability, we're looking at the theory. What should happen? What do we have? Versus empirical, we're looking at past data we've collected. So in this case, we use our past data to figure out how big is our sample space, and then how many ways meet the criteria we're talking about. And you'll see that formula here. The probability of an event, the denominator is n. What was our total frequency for the frequency distribution? The numerator is f. How many, if it's one class or more than one class, some of them, how many of that n actually make the statement true? All right, now, the rules of probability are the last thing we're going to cover in this particular video. If an event, before I start that, do not get tangled up in the numbers of these. Don't worry, okay, is that probability rule 3 or probability rule 4? I'm not going to ask you which number's which. The important thing here is that you retain the concepts and understand what their meaning is for you in trying to solve problems. Okay, so the first rule of probability, if an event cannot occur, its probability is 0. Now, if we think about that in terms of an example, and hopefully I can show this on the screen here. See, I have a 6-sided die here. Unfortunately, it's black, kind of dark, but normal 6-sided die. If I was going to roll this die one time, and I want to know what is the probability that the result is 37. Well, if I think about this in terms of classical probability, when I roll this 6-sided die, 6 things can happen. So my denominator is 6. For the numerator, then I need, okay, how many of them how many of them match my criteria? In this case, how many of them are equal to 37? The answer is none of them. I mean, they're 1 through 6, so it's 0. So my probability of rolling a 37 is 0 over 6. 0 over anything is just 0. So if an event cannot occur, if it's impossible, probability is 0. Now, flip side of that, if an event is absolutely certain, just has to happen, the probability is 1. Again, go to our six-sided die. If I say, okay, I'm going to roll this six-sided die once, what's the probability that the result is less than 9? All right, once again, I look at that. Look at my denominator. What's my sample space? 6 things can happen, 1 through 6. So denominator 6. Numerator, how many of them meet my criteria? All right, how many of those 6 are less than 9? Well, all 6. So my probability is 6 over 6. Even if you don't like fractions, you got a pretty good chance of getting that one, saying 6 divided by 6 is 1. So if an event is absolutely certain, its probability is 1. Now, the next rule kind of closes the loop with the two we just covered. The probability for any event will be between 0 and 1 inclusive. Okay, this should make sense. If an event is impossible, then its probability is 0. If it's absolutely certain, the probability is 1. So the probability has to be somewhere in that span. We can't go below 0. Can't have a negative probability. We can't go above 1. What's particularly nice, one of the ways you can also represent probabilities is with percentages. If you think about this, that covers the range from 0% to 100%. So that rule just kind of closes the loop from the first two. Now, the fourth item, the sum of all the probabilities of outcomes in a sample space is equal to 1. If you take and look at the outcome of all the possibilities, it has to total 1. If you think back to our single die example, if we add up the probability of a 1 plus the probability of 2 plus the probability of 3, 4, 5, and 6, if we add those 6 probabilities up, the total should be 1 because we've covered all the possibilities in the sample space. And then there is one particular application of this. If you think about it, the probability that an event will occur plus the probability that an event will not occur is 1. Now, the reason that's important, sometimes it's much easier to compute the probability that something won't happen. And that will allow you to essentially back into the probability that it will happen. So you can look up more information on that in the rule for complementary events. So this is it for section 4-1.